Hello everyone, welcome to my channel. In this video we will learn about the introduction to algorithms. So this series of videos cover about the different concepts in the algorithms. What is meant by an algorithm? Algorithm is a step-by-step process of solving a problem. So it is a step-by-step process of finding out a solution for a particular problem. So before going to know about the algorithms, let us know why do we need to learn the algorithms. So if we learn the algorithms, so we can easily solve the problems. So it lays a problem solving foundation. So algorithms will teach you a structured approach to solve the problems. By breaking down a problem into clear steps, you can develop logical solutions that can be applied to many different situations, even beyond computer science. Efficiency. Understanding algorithms helps you evaluate how effectively a task is being completed. This is critical in computer science as different algorithms can solve the same problem but require varying amounts of time and resources. Knowing about algorithms allows you to choose the most efficient approach for a given situation. Next is coding foundation. So we have to learn the algorithms if you want to become a good programmer. Algorithms are the building blocks of computer programs. When you write code, you are essentially translating an algorithm into a language that a computer can understand. So a strong understanding of algorithms must be needed here. So a strong understanding of algorithms is essential for writing effective and efficient programs. So next one is real world applications. Algorithms are everywhere in our daily lives, from social media feeds to recommendation systems, from traffic routing to fraud detection. Algorithms play a significant role in how technology works. Understanding algorithms gives you a deeper appreciation of how this technology functions. Next, critical thinking. The process of analyzing and designing algorithms, it will boost your critical thinking skills. You learn to break down complex problems, identify key steps and evaluate different approaches. This critical thinking is valuable in many aspects of life, not just in computer science. So these are the 5 things that comes under why do we need to learn algorithms concept. So next we will see what is an algorithm. An algorithm is a set of well-defined instructions that describes how to solve a specific problem step by step. So algorithm is a step-by-step process of how to solve a particular problem. So by following this step-by-step process, we can find the solution of a particular problem. Let us suppose you want to prepare a dish. So there will be some set of instructions to follow to prepare that dish. Right? So these steps are called as an algorithm. So next, characteristics of the algorithm: finiteness and ambiguity, input, output and effectiveness. The algorithm must be finite. That means it must have some starting and ending point. If an algorithm is infinite, then a computer can't understand the algorithm. So we can't write a good program from the algorithm. Okay, algorithm must have a starting and ending point. If it is infinite, then it is difficult for a computer to run that algorithm. It should terminate after a finite number of steps. Unambiguity. That means the algorithm must be very clear and precise. Okay, so algorithm must clearly mention the purpose of the algorithm. Okay, so it must find out the solution for the particular problem. And input. An algorithm typically takes some form of input data. And output. So it takes some data from the user and it generates some output to the user. Okay, suppose a product of two matrices. So here in the product of two matrices, it is taking the input from the user, that is the numbers, and generating the solution, that is the product of two matrices as the output. Effectiveness. An algorithm should be very efficient and solve the problem in a reasonable amount of time and sources. So before going to know about the algorithm, so let us clearly know the difference between program and algorithm. An algorithm is a set of well-defined instructions that outlines a step-by-step process to solve a specific problem or to complete a task. So it clearly defines the process of how to solve a problem. For suppose I want to prepare a tea. So I'm a beginner, so I don't know how to prepare a tea. So just I will follow the simple steps of how to prepare a tea. So first of all, we have to take some water and boil the water and add some tea leaves and then add some milk and sugar. So this is the step-by-step process, the procedure of making a tea. So these are the steps, right? So it is the instructions given to prepare the tea. So algorithm is nothing but instructions given. And program means the prepared dish, the final output is the program. Algorithms can be expressed in various ways like plain English, flowcharts or pseudocode. Okay, so we can represent the algorithm in a plain English and a flowchart diagram and through the code. So we can write any number of programs from a algorithm. The focus of an algorithm is on the logic and the sequence of steps needed to achieve the desired outcome. So here the main focus is on the logic and the steps followed to get the particular output. So this is about the algorithm. So now let us see about the program. A program is the actual implementation of an algorithm in a specific programming language. So it is the implementation of algorithm. Generally the algorithm will be in a normal English like text. So it will be in a written in English language. So we are not following any syntax or semantic rules, right? So we are just writing in a simple way such that any user can understand the functionality of the particular algorithm. So here the program is the implementation of the algorithm. So in the previous example we discussed it, right? So algorithm is the instructions given how to prepare a tea. And if you are following that instructions and prepared a tea, then it is nothing but a program. If you are following that instructions, then it will become the program. So it's like following a recipe using specific ingredients and measurements. So here we have, in the algorithm we have given some instructions, and if you are following that instructions and preparing the recipe, then it is nothing but a program. Programs are written according to the syntax and the rules of the chosen programming language. So here we are following the syntax rules of the particular language that we are choosing to write the program. So like C, C++, Java, Python. So we are having number of programming languages, right? So we can write an algorithm in any program. And if you are writing the algorithm in that program, then we must follow the syntax and semantic rules of that programming language. The program translates the general steps of the algorithm into instructions the computer can understand and execute. So it will translate the simple steps of the algorithm into a format that the computer can easily understand and execute. So we can't directly run the algorithm, right? So we have to convert that into a programming language. Then only we can implement that algorithm. So simply, program is nothing but the implementation part of the algorithm. So for example, if you are constructing a house, then first of all we have to prepare, right? We have to make a blueprint of that house. Okay, so how many bedrooms you want in your house, and what is the square feet of the place that you want to build your house, right? Like which type of house you want to build, like a normal simple house or like a duplex house. So we have to consider all these things while drawing the blueprint. Okay, so this is the algorithm, that is, so we are mentioning just the normal how the house will be, the plan of the house. And in the program, so after building a house according to the blueprint, then it will become a program. So example of program is a house and algorithm is a blueprint. An algorithm can be written in many ways. So we discussed it already. So algorithm can be in different formats. That it can be in plain English and flowchart, and then in pseudocode. So here I am preparing a flowchart for the concept of preparing a sandwich. Okay, so preparing a peanut butter and jelly sandwich. Okay, so first of all start here, start in the flowchart diagram, and then so to prepare this sandwich, so we need some bread. Basically, if you want to prepare a sandwich, we need some bread. So we are checking whether the bread is available or not in this diagram. So here is the bread. So if the bread is there, then we will go to the next part, that is peanut butter and jelly available or not. If the peanut butter and jelly are not available, then again we will go to the start point. Okay, so if the peanut butter and jelly are also available, then we need to spread the peanut butter on the one slice of the bread and spread jelly on the other slice of the bread. Put the slices together and enjoy the sandwich. Okay, so first we have to check whether the bread is available or not. So if the bread is not available, then we will again go to the starting point. So if the bread is available, then we will go to the next decision box, that is in the rhombus shape, whether the peanut butter and jelly are available or not. So if it is available, then we will go to the further steps and we'll prepare a sandwich. So this is the flow chart of preparing a sandwich. So now let's see the code of this flow chart. So this is the pseudocode of the flow chart. So here first of all we are checking whether the bread is available or not. So if the bread is available, then we will go whether the peanut butter and jelly are available or not. So if these two things are available, then we can spread the peanut butter on one slice of bread and spread jelly on the other slice of bread. Put the slices together with peanut butter and jelly facing each other. So we are coming out of the if class, and we can, so here the sandwich is done and we can enjoy our sandwich. So this is the pseudocode developed for the flowchart. Okay, so in the plain English here I want to prepare so I can tell you how to prepare a sandwich, the peanut butter and jelly sandwich. So we have represented the same thing in the flowchart part and then in the format of the code. Okay, so this is about the introduction to algorithms. Thanks for watching my video.